Hello everyone, welcome to my channel. So today I'm again back with a new video. So in this video we are going to solve this problem. The problem is a little bit complex, but if you watch this video till the end, then you will find it much easier than it is. So without wasting time, let us move towards the video. So let me read it out, the question which we are going to solve today. The question is, if a equals to root 10 plus root 5 upon root 10 minus root 5 and b equals to root 10 minus root 5 upon root 10 plus root 5, then show that root a minus root b minus 2 root ab equals to 0. In this question we need to show that it is equal to 0. We will put the value of a and b to get the answer. So first of all, let me determine the value of root a. For this root, this is under root sign, and then I'll put the value of a. The value of a is given root 10 plus root 5 upon root 10 minus root 5. Okay, I put the value of root a here. Now I will rationalize its denominator so that I make it rational. The denominator is to be rational. So let us move towards the calculation. Root 10 plus root 5, I am going to put a bracket here, and I am also going to put the bracket in the denominator. As you know, when we rationalize a number, then we multiply it with the conjugate pairs. So what are conjugate pairs? Conjugate pairs are those with the opposite sign, such that there are two digits, root 10 minus root 5. The conjugate pair will be root 10 plus root 5. But if I multiply it on just in the denominator, the value would change. So that the value does not change, the whole value remains same, I need to multiply it with the numerator also. Whenever we multiply same number with the numerator and denominator, the value does not change. Here, do you think I can apply any identity? Yes, in the denominator I can apply identity. A plus b multiplied by a minus b equals to a square minus b square. So here in the denominator, a is root 10 square minus root 5 square, which is equal to 10 minus 5 equals to 5. So the denominator is 5. Now I can write the numerator as, numerator can be written as, I'm writing in numerator is root 10 plus root 5 multiplied by root 10 plus root 5. It can be written as root 10 plus root 5 whole square, and the root sign is as it is. Don't forget to write this sign. And in the denominator, I calculated the denominator by identity a plus b multiplied by a minus b equals to a square minus b square. So the denominator is 5. I can also write it like this: root 10 plus root 5 square. Now when there is square root sign and here is the square sign, actually this is whole square, then both of these signs cut each other. This power cuts this sign, and in the denominator I need to write it like this. So here these signs cut each other. So now I am left over with root 10 plus root 5 upon root 5. Okay, this is the value of root a. Let me put it as equation number 1. Now I will calculate the value of root b as given in the asked question. See, this is the value of root b, root 10 minus root 5 upon root 10 plus root 5. Here I am going to put its value. In this I found the value of root a, which is equation number 1. You can see this is equation number 1, and for root b now we'll solve its value. Root b, the value of b is root 10 minus root 5 upon root 10 plus root 5, and this is root b. Now again I am going to rationalize it. So whenever we rationalize, we multiply the numerator and denominator by the conjugate pair. It's the same process in root a and root b here, but the sign in the denominator is opposite. Here the sign in the denominator is addition sign, so the conjugate pair of this sign would be minus, so it will be root 10 minus root 5, and I need to multiply it to the numerator also, root 10 minus root 5. Now again I can apply the same identity. A plus b multiplied by a minus b equals to a square minus b square. Root 10 square, which is a, minus root 5 square, which is b. 10 minus 5 equals to 5. The denominator is 5. See, the denominator is 5. Now I will calculate the numerator. You can see in this root 10 minus root 5 multiplied by root 10 minus root 5, it can be written as root 10 minus root 5 whole square. I am putting this sign, root 10 minus root 5 whole square, because root 10 minus root 5 was multiplied 2 times, and we know the denominator is 5 by using this identity. First step is rationalization in such questions, so don't forget to rationalize, and then the solution will be there. Then for the denominator is 5. Now for this I can also write it like this, root 10 minus root 5 square upon root 5. Okay, we can write it like this, and this power will be cut by this sign of square root. I am going to cut it, so what I get is root 10 minus root 5 upon root 5. Okay, you can see. Now we'll make it an equation. Root b equals to root 10 minus root 5 upon root 5. I can write it as equation number 2. So let me take a glance of what I have just told you, that we are asked that root a minus root b. I found the value of root a, yes. I found the value of root b, yes, equation number 2. Now what I am left over with is root ab. So let me solve this. Now we'll calculate its value, root ab. What is the value of a? The value of a is root 10 plus root 5 upon root 10 minus root 5 multiply by b. The value of b is root 10 minus root 5 upon root 10 plus root 5. You can see I can cut them. Root 10 plus root 5 is cut by root 10 plus root 5, and this is cut by this. So what I am left over with is root 1, which is equal to 1. So let me write down the equation which I am told to prove. See, this is what I need to prove. Root a minus root b minus 2 root ab. I forgot to write it as equation number 3. This is the equation number 3. Now with the help of these 3 equations, this is equation number 1, root a, root b and root ab. I will solve this equation. I'll prove this equation. So value of root a by equation number 1, the value is root 10 plus root 5 upon root 5. Root 10 plus root 5 upon root 5 minus root b, the value of root b by equation number 2, the value is root 10 minus root 5 upon root 5. And the value of root AB with the help of equation number 3, root AB is 1, so minus 2 multiplied by 1, which is equal to 2, equals to 0. Now we'll prove this. For this I need to solve this. The denominators are same. There here is minus sign of subtraction. Then I will write it like this: root 10 plus root 5 minus root 10 plus root 5, because minus minus is plus, plus root 5. Then this root 10 will be cut with root 10. Now I am left over with 2 root 5 upon root 5, because here was this denominator. I had ignored this denominator in this step, but in this step I am writing the denominator because this is the value. Don't forget to write this denominator. Minus 2 equals to 0. This root 5 will be cut by this root 5, then 2 minus 2 equals to 0. Hence I have proved this equation. So let me quickly recapitulate. First of all, I calculated the value of root a by rationalization, by conjugate pairs. Then I found a numerator and denominator, and I got the equation number 1. Then I solved for root b, and then by rationalization I got the answer. I got equation number 2. Then I calculated root ab and I got its value after cutting, and then I solved for this equation and I put the value of these in this equation, and then after solving I got that 2 minus 2 equals to 0. So hence I have proved this, and I hope you like this video. I'll soon come back with a new video.